Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Let me introduce myself. My name is Wisnu Prasetyo from 11 Maret University. On this occasion, I want to present research with the title Enhancing Tensile Strength and Porosity of Cell-Compacting Concrete with Glass-Based Powder. Construction technology advanced more and more rapidly along with the development of the times. Similarly, the development of concrete technology to meet the challenge of today's industry. Notice the world needs concrete with high performance, high durability, and high workability, where the conventional way of compaction may not always work well under the condition of the content of different situations. So, what's the solution? The solution is we use self-compacting concrete. Self-compacting concrete is concrete with high flowability with low segregation levels that can spread the flat of formwork and solidification itself reinforcement without a manual compaction process. The setting of aggregate size, aggregate compression, and X-meter solid are the factors that make self-compacting concrete capable of compacted independently. And this is the advantages from self-compacting concrete and according to Okamura and Oji. But we have another problem. Self-compacting concrete requires a lot of cement, which in cement production has a negative effect for environment. The amount of material that is carried out from production activities will negatively impact to the environment such as acid rain, respiratory disorders, and to add a crust to the roof of building or housing. So, we change cement with glass-based powder. And then why we choose waste glass material first cannot be recycled. And then, according to data from Ministry of Environment on 2013, waste glass material contribute 1.7% from 870,000 tons of trash. And the second is pozzolanic in powder form, third contains silica in powder form, and the last is when dropped into micro-sized particles, experiencing a reaction with cement hydrate forming secondary calcium silicate hydrate. And this is the other advantages from waste glass material. And this is the purpose from the research. First, to know we need to know the effect of replacement cement with glass with powder on tensile strength and porosity of self-compacting concrete in 28 days. And the second is to get the optimal percentage of glass with powder in order to obtain maximum tensile strength and minimum porosity of self-compacting concrete on 28 days. And this is the percentage variation of glass with powder. And then this is the standard testing and material specification. There is glass powder, mixed design, super plasticizer, porosity testing, tensile strength testing. And this is the flow diagram of research methodology. And this is the process of making powder glass. The glass powder that have been collected are cleaned and then we wait until dry and put into the Los Angeles machine. This is the machine. And we turn on the Los Angeles machine on 20x minutes 5 times. And after smooth out using the Los Angeles machine, then the glass-based powder is ejected and put on the tray. Glass-based powder that has been smooth enough then filter using a sieve number 100. Repeat all the steps above until the glass-based powder needs are met. And this is the results from tensile strength testing result and porosity testing result. On the tensile strength testing result, we get 5.5% percentage and we get the maximum tensile strength 3.422 megapascal. And the porosity of testing results on the glass material powder is 8.583% and the average porosity is 9.806%. And then this is the tensile strength testing results. For the glass-based powder variation of 5.5%, obtain the optimal values of glass-based powder variation and obtain a strong value of the maximum tensing of 3.422 megapascal. There is a strong increase in drag because of the pozzolan glass-based powder is material containing silica and alumina. The compound will react chemically with calcium hydroxide at room temperature and form compounds that have properties like cement, according to national standard on 2004. And on variation of glass with powder on 25% and 30%, the tensile strength of concrete is decreased. This is the porosity testing result. For fraction of glass with powder of 8.583% obtain the optimal values of glass with powder variation of the value minimum of porosity, which is at 9.806%. The effect of being seen in the table glass with powder, the pozzolanic can be a substitute for cement. In powder with glass much contains silica. That chemical reaction is between the silica particle of glass grain, the alkali matter of the cement grain. This reaction is called alkali reaction. This reaction creates a gel which can swell and cause concrete cracks if precautions are not enforced in the formation of concrete mixture, according to Cyan and Xu in 2004. So the gel was able to fill the pores of the self-compacting concrete. And the second condition is when the rise of porosity, the effect caused by glass with water is not absorbing water. Water is one of the biggest porosity in file concrete. This is because the water element is composed of hydrogen and oxygen. Moreover, the size of the glass was water screen greater than cement, so that the surface area is smaller than the glass water. With its neither does not absorb water and the surface area is smaller than the moisture content in fresh concrete becomes much less, and after the dry concrete causes the pore. And this is the conclusion. First, we got the glass with powder variation in replacement of some cement has a significant effect on the tensile strength and porosity of the self-compacting concrete. And the second is the optimal rate of addition of glass with powder resulting in maximum tensile strength of the self-compacting concrete is at a percentage of 5.5% at 3.422 megapascal. The optimum addition of glass with powder resulting in minimal porosity of self-compacting concrete is at percentage of 8.583% at 9.806%. This is my presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.